Okay, today we're going to be looking at proving Theorem 11. Now, Theorem 11, we first met this in junior cycle in third year, states if three parallel lines cut off equal segments on some transversal line, then they will cut off equal segments on any other transversal. Now, you need to learn exactly what that means. You need to be able to get started on this particular theorem, and you need to adopt the structured approach which they present to you in the exam. And the structured approach starts off with being able to draw a diagram. So what we're going to look at now is you must be able to draw this diagram. Double check, make sure this diagram matches what it says in the theorem statement. So there's your three parallel lines, L1, L2, L3, and it cuts off equal segments of some transversal line, which is ABC. And as you can see, there's equal segments. And what the theorem states is, as a consequence of this, it also means that DE will be equal to EF. Those segments will be equal to. And now we're going to embark on the proof and how we actually do this. So the first thing is, as I say, get the diagram right. Second thing is they'll give you a heading which says given. So you're using your diagram, write down in simple terms the information that you were given in the statement. So what were we given? Well, we were given that the line L1, i.e. the line going through DA or AD, is parallel to L2, the line going through BE, is parallel to L3, the line going through FC. We're also told that the length AB is equal to the length BC. So we write that information down, and when we do, we get marks for it. And then we state what we need to prove. And what we're trying to prove is we're trying to prove that the length DE is equal to the length EF. Now, in order to do this proof, we have to draw extra lines on this diagram. If you're going to draw extra lines on the diagram, you've got two options. You either redraw the diagram again with the constructions on it, waste of time possibly, or using a different colour pen, blue, you draw the construction lines on the existing diagram. And the point is, you must comment on it. So we'll just draw the construction lines first, and then we'll talk about it. In order to actually be able to do this proof, you have to draw a line from A to E dash to F dash, which is parallel to D, E, and F. Once you've drawn that first blue line, you then got to draw this line, a construction of the line which is parallel to ABC, hence being called A dashed, B dashed, and then it joins up at F. Now it's absolutely essential that you draw those construction lines and write it down in words as well. And once you've done that, then you can begin to undertake the proof. So basically, what are we trying to do here? Well, eventually we need to show that this length here is equal to that length there. Let's give a quick overview of what this proof is about before we actually set out and prove it. What do we know from construction? We know that this is a parallelogram. That's fine. And if it's a parallelogram, we know that this length here, AE dashed, will be equal to DE. And we know from this parallelogram that opposite sides of a parallelogram are equal, so we know that EF length is equal to E dashed F dash length. So that's great. We know that from the properties of parallelograms and from proofs in junior cycle. Now, so if we can prove that AE dashed is equal to E dashed F dashed, then we've shown that DE is equal to EF. So how do we show that this length and that length are equal? Well, the techniques we used in the junior cycle is we focused on congruent triangles. So we're going to focus on the triangle here and the triangle there. So this is what our proof is actually based on, is looking at focusing on these two triangles. So, and we need to show that they are congruent. And if we show that they are congruent, then we are going to prove that this length here and that length there are equal. That's what we're trying to do. So, right, okay. So what we're going to be doing now is taking that journey. Now, the first part of that journey is, what do we know about this length here? Well, we know that this length here has to be equal to that length. You ask yourself, why? Well, this is a parallelogram. Well, how do I know this is a parallelogram? Well, first of all, we were told in the question that L2 and L3 were parallel. And also, we constructed these two lines. And we constructed these two lines to be parallel to each other. And thereby, we've created a parallelogram. So we now know that that length equals that length. But now we've got to write it up. We see it in the diagram, but now we've got to write it up. So what do we say here? Well, we've already said that that's equal. So we then write it down. B dash to F dash is equal to BC. And then we give a reason, opposite sides of a parallelogram. So the important thing is you spot something, you draw something on your diagram, and then you write it in words afterwards. Okay, so what we're looking at now, what else do we know from this diagram? Well, we actually do know that these two angles are equal. You know, they look the same. Are they the same? Well, let's have a look. Well, we know that, that this line here and this line here, by construction, are parallel. And if those are parallel lines, then this line is the transversal. And therefore, because they're parallel lines and this line is the transversal, we've actually got Z angles. So we have got these two angles are equal, and they're equal because they are Z angles, alternate angles. Right, great. So that's on our way to looking at trying to prove that these two grey triangles are congruent. Now, the method of proof I'm going to employ is I'm going to employ angle, side, angle. Now, so what am I going to do next? What am I going to do next? I mean, it's not the only way to do it. It's not the quickest way to do it. But I'm going to actually have a look at these two angles here. And these two angles here I know are definitely equal. And the reason why they're definitely equal, I know they're definitely equal, I have to give a reason in order to get the marks of the proof, is because, can you remember what they're called? You might want to pause the video, see if you can get it right. They're called vertically opposite angles. Okay, so now there's this angle here. Now there's two ways of proving that this angle and that angle are equal. I can say, right, they're the third angle in a triangle. That's one way. Or I could actually say, use what I did in the very first angle. That line and that line are parallel. And this is now the line B to B dashed is the transversal. So therefore, parallel line, transversal, parallel line, I've actually got Z angles. So for line 4, I know those two angles are equal by either the third angle in a triangle or by the fact that they are also alternate angles. Right then, going on to line 5. Sorry about spelling that incorrectly. I'm sure you can correct that yourselves. Going on to line 5, what do we now know? Well, we now know that these two triangles are congruent. How do we know they're congruent? By angle, side, angle. Simple as. So they're congruent, and the reason why they're congruent is angle, side, angle. That means all corresponding sides must now be equal. So this side here, AE dash, goes from red dot to star. And there's a red dot to star here, which means AE dashed and E dash to F dashed must be, they must be equal. And because, and then we write that down. Once you've identified it, we need to write that down. And there it is. AE dashed and E dashed F dashed are equal in length. I forgot to put the modulus symbols in, please forgive me. Okay, there's no reason for that. Oh, we could just say bicongruent triangles. Okay, so what do we now know? Well, we now know that that and that are equal. But we also know, by the virtue of the fact that this is a parallelogram, that DE is equal to AE dashed. And we also know that EF, by virtue that this is a parallelogram, is equal to E dashed F dashed. So we can write this down. And as I said, the reasons we've already established it is because they are opposite sides of a parallelogram. Well, if DE is equal to this, and EF is equal to this, and these two items we've already established are equal to each other, well, that means line 8 follows very simply. DE is equal to EF, and proof follows. Okay, and that's the end of the proof. You need to go over that a few times, make sure you learn it. That particular question is probably worth 10 marks in any given exam. Thank you.